Okay, so now that we've done empirical formula, let's do molecular formula. So molecular formula is equal to, and you can write this on to your periodic tables, it's equal to the empirical formula, I'm just going to abbreviate, times N. And so N is actually, and again, you can write N on there. Oops, arrowed down for some crazy reason. Not where I want to be. N is equal to the molar, I'm going to put MM for that, the molar mass. This is not erasing for some reason. It's equal to the molar mass of compound over the molar mass of the empirical formula. Okay, so that means you're going to get a number like whatever that N is, and you're going to multiply it here. So let's start here. So first off, the steps for empirical formula, molecular formula, based on percent don't change. Guess what? If they don't give you percent and they actually give you grams, just use it the same way. Makes sense. So we're going to start. So we get 40. Oops, don't want to write in there. 40.68 grams of carbon. We're going to convert that into moles. Remember, step one is always convert to moles. So we get 1 mole C over 12 grams. Comes from the periodic table, that 12 does. And then we get 3.39. Oops. Write a little bit nicer here. 3.39 moles of carbon. We have 5.08 grams of hydrogen of H, 1 gram of H. We get 5.08 moles hydrogen. And then we do our 54.24 grams of oxygen. And we have 1 mole oxygen and 16 grams oxygen. And we get 3.39 moles of oxygen. Note I kept everything in scientific notation, 2 significant digits. Now, we have 2 that are 3.9, so let's divide all of it. Since 3.9 is the smallest number, again, the smallest moles is what we divide all of it by, 3.9 by all of these. And beautifully enough, we get 1 mole for 2 of them, for oxygen and for carbon. It always doesn't work out that beautifully, but it does. However, we get 1.5 moles of hydrogen. So because it's 1.5 is in a whole number, we multiply that by 2 to get 3 moles of hydrogen. And we have to get everything else by 2 as well, giving us 2 moles of carbon and 2 moles of oxygen. So if we would write this completely out, and I'm going to have to give myself a little bit more room here because I didn't leave enough space. So we're going to arrow this down just a little bit more. So if we write this completely out now based on what we have, you have C2H3O2. So let's find the molar mass of this compound. So we're going to take carbon is 12. So we have 12 times 2 plus hydrogen's 1, so 3 times 1 plus we have 16 times 2. There should be a 2 here. And we're going to find the molar mass of the compound is going to be 59 grams per mole. And so that's what the compound that we have, that we found out. So now we have to find N, because if we look up here at the top, we saw that we are giving a molar mass of this compound to be 118.1 grams per mole. So we're going to find N. So N again is equal to the molar mass of the compound. Well, that was given the equation. It has to be given to us in the equation. 118.1. And then we determined this molar mass here, which is the molar mass of the empirical formula. And so that was our 59. And so N is going to be 2. So basically what we do is we take this 2 that we just solved for here, and we're going to multiply it by this. And so the empirical formula for this would equal C4, because we're multiplying it by 2, H6O4. And so that's the empirical formula. Now here's a good way to double check. Take this empirical formula, 4 times 12 plus 6, because we have 6 oxygen, and 4 times 16. And when you get this, you should get, if we use the right thing, you should get 118. And so that's a good way to double check that you have the right one. Okay, so let's go ahead and do this next one. So again, we're going to start with the information we have right here. We're converting those into moles. I'm going to arrow down really quickly. I'm going to put a page break in here so I can have a little bit more room. Here we go. So now let's use that equation. So we have 57.7 grams. Again, turning that into grams. Again, if they have grams already for you, you don't have to turn that percent in. That works out great. When we look at the periodic table, the molar mass of carbon is 12, 1 mole, and we have 6.31 moles of carbon, which gives us, gotta wait for that step. We got 8.8 grams of hydrogen. Again, hydrogen's an easy one because it's 1 and 1. It's 8.8 mole hydrogen. And our last one is going to be 5.5 grams of oxygen. 1 mole, 16 grams of oxygen is equals 0.97 grams of oxygen. Well, obviously our smallest one is 0.97. So divide all of it by 0.97. Oh, it's too far. And we get 6.5 moles of carbon. You get 9.0 moles of hydrogen. Oops. And we get 1 mole of oxygen. Okay, that's 6.5. Totally throws us off. We have to multiply everything by 2 now. And so in this case, you get 13 moles of carbon, 18 moles of hydrogen, and you get 2 moles of oxygen. Okay, so let's go down here. Let's put that into our equation. So now we have C13H18O2. Find the molar mass of this. 13 times 12 plus 18 plus 16 times 2. We get a molar mass of 206 grams per mole. Okay, so let's put that into N. Well, we have 206. Well, if we look at the equation above, we have 206 as well. It equals 1. Because this equals 1 here, that means this is the same. So our empirical formula and our molecular formula are the same for this compound. You can look at section 3 for the additional problems, and have a good day.